All right, so welcome to part 2 of this Unit 4 exam review. So we're going to start with number 6. What is the percent composition of each element in this compound? So for percent composition, what we want to do first is find the whole total mass of this. The whole mass of this whole compound. So I know that I have 1 atom of copper. I know that I have, see this little 2 right here? This little 2 means that I have 2 atoms of chlorine. When it's outside the parentheses, it means that it multiplies a little subscript. So I have 2 atoms of chlorine. And then that same little 2 is going to multiply into these inside, let me do that again with a different color thinner. There it goes. So I know this little 2 is also going to multiply this inside subscript. So 2 times 3 is 6. So I have 6 oxygen atoms. 6 oxygen atoms. All right. So now I'm ready to go and find the mass for each of these elements. So if you look at the periodic table, copper has a mass of 63.546 grams, or atomic mass units, whichever you prefer. Chlorine, let me look it up real quick. There it goes. Chlorine has a mass in the periodic table of 35.453, but I have 2 atoms of chlorine, so I'm going to multiply that by 2. And then oxygen has a mass of 15.999, but I have 6 atoms of oxygen here, so I'm going to multiply my number by 6. So now I'm going to go and do these multiplications, so then I can add all of these individual elements into one total mass. So 35.453 times 2 is equal to 70.906. 15.999 times 6 is 95.994. So now I have all of the masses of each element in my compound right here and multiplied by however many atoms there were. So now I have to go and add all of these so that I can find the total mass of my compound. So 95.994 plus 70.906 plus 63.546 is equal to 230.446 grams atomic mass units, whichever mass unit you want to give it to. Okay, so now that I have my total mass, I can go in and make fractions to see which percent each one of these elements makes into my total mass. So how we're going to do that is just a simple formula. So if I wanted to find the percent mass of copper, what I'm going to do is have the mass that I have of copper, so 63.546, and I'm going to divide that by my total mass of 230.446. And that, and then I have to multiply that by 100 because it is a percent composition, so percent means times 100. So now I can go into my calculator and say, okay, well, what is 63.546 divided by 230.446? And that is 0.276 approximately times 100 is equal to 27.6%. So to recap, I took the mass that I found of copper right here. I put it at the top. because I'm finding copper. And then I took the mass, the total mass of my whole compound and put it below. And then I multiplied by 100 to make it a percent, and I got the percentage of copper. So now let's do that for chlorine. Let's do it up here. For chlorine. So the mass that I have for chlorine is 70.906. That's a total mass that chlorine makes up into my compound. I'm going to divide that by the total mass that we found, not that one. The total mass of the compound right here. So 230.446. And then all of that times 100. All right, so now I can get in my calculator and say, all right, what is 70.906 divided by 230.446? And then times 100 is equal to 30.8%. And I am approximating only to the first decimal place, by the way. So, one more time. I took the mass that I found of chlorine, the total mass, so this one, right here, I put it on top of the fraction. Then I took the total mass of the compound that we found and put it at the bottom, times 100 to find the percentage of chlorine. Now I have one more left, and that is oxygen. So oxygen, I found that the total mass of oxygen was 95.994. 95.994. I know this looks like 4s, those are 9s. There it goes. Divided by the total mass, which is 230.446. And then I have to multiply all of this by 100. So now I get on my calculator. All you're doing here is just finding a fraction. 95.994 divided by 230.446 times 100 is equal to, I'll put it right here, 41.7 approximately percent. 41.7%. So to recap one more time again, let me get this one, that was pretty. I went and found the mass of oxygen in my compound. Remember, I had to multiply by the subscripts. Put it at the top of my equation, and then went and found the total mass of my compound and put it at the bottom, multiply by 100 to get my percentage. There's a little trick to see if you've done all of this right. You can add each one of your compounds up, the percentage, and all of them, if you add them up, whoa, sorry about that, should add up to 100. Unless you had to like approximate, which is what I did, then things might be a little bit off, but they should all add up to around 100%. Okay, now let's move on to number 7. So we are solving for the empirical formula. It's a little slow because I'm writing so much on this screen. There it goes. Okay. A compound has 70 grams of carbon, 8.75 grams of hydrogen, and 47 grams of oxygen. They give me the molar mass, and then they ask me to find the empirical formula. So, first things first, determine the mass of each element. Check, they already gave it to me. Carbon is 70 grams, hydrogen is 8.75, oxygen is 47. Convert the mass of each element to moles. Okay, so if I want to do it for carbon, have carbon right here. If I want to do it for carbon, I have 70 grams of carbon. I need to convert this to moles. I know that the only way I can do this is if I cancel out my grams and leave moles at the top. And I know that I can recognize that grams and moles, that's molar mass. The molar mass of carbon, if you look at the periodic table, is that there is 12.011 grams per 1 mole of carbon. Then I can see that my grams cancel out because they're at the top and the bottom. And all I have left to do is do the math. 70 above 12.011, that means I have to divide 70 divided by 12.011, which is 5.83 moles. All right, so now I can do the same thing for hydrogen. So I have hydrogen, hydrogen right here. I have 8.75 grams of hydrogen. I need to multiply that so that my grams cancel out. So I'm going to put grams at the bottom. And I only want moles, so I'm going to put moles at the top. I know by looking at my periodic table, my molar mass of hydrogen is 1.008 grams per 1 mole. Now I can solve it. I see that my grams cancel out. I'm only left with moles, which is what I wanted. And now I only have to do the math, which is dividing 8.75 divided by 1.008. And that is 8.68 moles. All right, so now I only have to do it for oxygen since it's the last element. So I'm going to do it right here. Oxygen. I start with 47 grams of oxygen. I know that I need to cancel out these grams and be left with moles. So I'm going to put grams at the bottom, moles at the top. If I look at the periodic table, I can see that there are 15.999 grams in 1 mole. And then I get my calculator and I'm like, all right, 47 divided by 15.999 is equal to 2.94 moles. I know that this is moles because my grams canceled out here and all I was left with is moles. Okay, so I did number 2. Boom, check mark. Find the mole-to-mole ratio for each element. Divide the number of moles of each element by the smallest number of moles. Okay, so I have a whole bunch, like whole numbers, but they have decimal places. I'm going to approximate that this one is actually a 6 moles. This one is actually 9 moles. And this one is actually 3 moles. So I go back and read number 3. I have to find the ratios for each element and divide the number of moles by the smallest number that so each of these numbers, 6, 9, and 3, I have to divide them all by the same number so that they have the smallest ratio. I know that 6, 9, and 3 have a common ratio of 3. If I take this one and divide it by 3, it is equal to 1. If I take this one and divide it by 3, it is equal to 2. 6 divided by 3 is 2. If I take this one and divide it by 3, 9 divided by 3 is 3. So I have 2 moles of carbon, 3 moles of hydrogen, and 1 mole of oxygen. And I can no longer get these numbers to a smaller ratio because I can't divide anything to make them smaller. So I did number 3. Number 4 I'm going to skip because this is just if they are not whole numbers and if they're decimal places, so we're going to skip this section. Write the formula using the mole ratio as a subscript for the formula. Cool. So I have carbon, mole 2, so 2 subscript. Hydrogen, and then I have 3, so H3. And then I have oxygen with a 1, so I'm just going to leave oxygen as is. So to recap, I went and converted my grams into moles for each one of them. Then I went and found the smallest ratio. Let me get a different color highlighter. The smallest ratio between each of the elements in the compound, which was 2, 3, and 1. So I divided by the same number on all 3. And then I used those numbers to write my final empirical formula. And I know it's empirical because I can't get these numbers to be any smaller than they already are. And that is part 2, so hold on for part 3.